This video is going to present the implementation of the AWS design. So first is the data storage implementation. We have used S3, S3 Galaxy, DynamoDB, and RDS for the data storage. Amazon S3, which stands for the Simple Storage Service, is an advanced scalable object storage system offered by AWS that is suitable for financial organizations. It has an outstanding durability rate that supports huge data volumes. It is used for data storage, which allows users to store the transfer data. S3 Glacier is used for data preservation and backup. It is a secure, durable, and low-cost cloud storage service for data storage and long-term backup. S3 Glacier has a cost-effective storage pricing, which enables low-cost, long-term data retention required for financial data that must be retained for a long time. And it ensures data are always secure and in place, which is a great option for storing sensitive financial documents. AWS DynamoDB is used for executing high-performance applications. It is a non-SQL database service that provides fast and predictable performance with this seamless scalability. DynamoDB is particularly suitable for financial organizations, as it comes with built-in security features such as data encryption, and it can process high transaction rate with low latency, making sure time-sensitive financial transactions are being processed at an efficient rate. Amazon RDS Relational Database Service is used to assist with data transfer, backup, and recovery. It is a managed relational database service that makes it easier to set up, operate, and scale a relational data in the cloud and provide cost-efficient, resizable capacity for an industrial-standard relational database. It is capable of automatic disaster recovery and maintenance in order to support the high availability and durability of data that are essential for uninterrupted financial service. And let's go through the implementation. Okay, first is the Amazon S3, so we create buckets and choose the general purpose, give it a name, and we can leave it all as a default, but we can choose the access as well. So, and then just create bucket, and this is the one that we previously created. So we can upload the files from here and create folders. This is the one that I have previously uploaded. We can see the property, and we can add the actual public access permission from here. And the next one is S3 Glacier, so we can create a vault, just give it a name, and leave as default, create vault. And then we can see this one is previously created, so we can see the vault properties. And then is the Amazon DynamoDB. We can create a table, give it a name. So if we want to put ID, we can change to numbers, and let's say employee name for this one, and just leave it as string. And then choose the default setting for the tables and just create table. Okay, and this is the one previously created, and we can have an overview here. And the last one is the RDS. So we create a database. So we choose the easy grade because this is easy options, and we can choose MySQL and choose the free tile. And for the database name, you can just keep it, or we can change our team name, or any name. And we will just keep the master username as admin and change this one to the manage in AWS Security Manager. So this will create a password to manage through the lifecycle. And just create database. And here's the one we previously created. We can see the connectivity, the log and events. So here's a backup events and the configurations. And this is all for the data storage.
Hi, my name is Zhao Haochen. Let me tell you our AWS security. I divided them into three parts: network security, data security, and monitoring. And since we don't have an application, we have not developed web application firewall, WAF, because WAF and Schedule work together. DDoS attacks are not considered in this security design. Therefore, for the network security, I use only one component, network firewall. With AWS Network Firewall, you can define firewall rules or policies that provide fine-grained control over network traffic, and then centrally apply these policies or rules across virtual private clouds and accounts. There are three benefits: automatically scan the network firewall to protect managed infrastructure, protect the unique workload with a flexible engine, centrally manage security policies or rules across existing accounts and VPCs, and automatically enforce mandatory policy on new accounts. And to yeah, as you can see, it didn't work. So we turn to the Messi. For the data privacy, for the data security, Amazing Messi discovers sensitive data using machine learning and pattern matching, and provides visibility into data security risks and enable automated protection against these risks. And there are four advantages: automated sensitive data at scale, gain cost effective discovery of sensitive data in S3, monitoring data security and privacy, and reduce time. Yeah, refresh it. Yeah, you can see error 2. Security Hub, which automated AWS security checks and centralized security alerts. I should have put it on the next page, and the reason you can guess, of course. This one, yeah, it didn't work too. With CloudTrail Lake, you can ingest activity events from AWS and sources outside AWS, including other cloud providers, in-house applications, and SaaS applications running in the cloud or on permissions. In AWS, in this one, you can immutably store audit was events, easily generate audit reports required by internal policies and external regulations, detect on also authorized access and analyze activity logs using Amazon SQL-based queries. Now, even earlier with natural language query generation, powered using generative AI for user with less experts in writing SQL queries, or CloudTrail responds with real-based event bridge alerts and automated workflows. And this is my group cloud trio. You can see our sites and go to the S3 buckets. Go to yeah, you can see here it's logs, and go to this buckets property word no. Yeah, here. And the Command Ground Duty is a threat detection service that continuously monitor your AWS accounts, workloads, and data for uh, malicious activity. It combines machine learning and always integrated threats in intelligence from AWS and leading third parties to provide detailed security findings, help you achieve visibility and remnants. Go to the S3 bucket 2 and yes, events notification, and this is for the ground duties. You can try this one. Input a name and select one. Yeah, events and all live circle. Lambda function for the this destination, and this lambda I create for my group. Yeah. CloudWatch. CloudWatch is a service that monitoring applications response to performance changes, optimize sources use, and provides insights into operational health by collecting data across AWS sources resources. CloudWatch gives visibility into system-wide performance and allow user to set alarms, automatically react to changes, and gain unified view of operational health. CloudWatch, yeah. And dashboard. We cite 10,000 is the alarm line. If the attack or something is higher, this data, it could in alarm. And the pull requested for configuring this components is to add a permissions for the users, and go to the permission, go to the IAM and the group or users, which one you want. Go to my group and choose my name. Yeah, you can see here, these properties policies are all I created, and there are two ways to add properties. One is choose. Yeah, you can choose for your group or just choose for yourself. This policy is from AWS system, and if you want to create it by yourself, you can write some JSON code. Yeah, that's it.
Hello, I'm Tenzin Lungrik, and today I'll be presenting our AWS network security and connectivity setup design to support a secure finance environment. This setup aims to ensure secure access, data protection, and control connectivity within AWS. So in this slide, we have AWS VPC, where a logical isolated network in AWS where we implement all the network network configs. Then we have internet gateways where to allow VPC to connect to the internet. AWS route table, which acts as a virtual router. Next, and in the next slide, we have NetACL, subnet level security, and Net Gateway for it, which sits on a public network, a public subnet, but gives a private subnet a gateway for internet access. And then we have VPN for on-premises and AWS to be in a secure connection. So I'll give a quick demo on what we have done here. And so first of all, here I have the VPC that's for the isolated network for the our environment. And we have all the details down here, VPC. We just need to know what's the idea we're working on. That's /16 10.0. Then I created a subnet for our group, four different subnets of 2 different regions. And I have a private and public subnets. So Team 41 Finance public and Team 41 private subnet 1 and 2. And here the route table of subnets, which is basically the target is IGW for the for basically giving the public subnet and access to the internet straight away. Whereas for the private subnet, we see the route table, it is NetACL, giving it a secure way to access the internet, because NetACL sits in the public subnet. So that gives the private subnet an easy way and secure way. Next, we have the route tables here, and route tables have a subnet association. So if I check the private route tables, then it's associated with private subnets. And if I check the public routes associated with public subnets, and this is very important, that's a route table. Here again, the similar way IGW is connected for the public routes, and that's internet gateway, and for the private we have net. So this is for security purposes, enhancing the security in the environment. Then we have internet gateway. So we need to attach the internet gateway for the VPC to allow, and I've attached it here to allow internet access to the VPC. And this is all for internet gateway. Next, we have elastic IPs. So during subnet configs, I couldn't assign the I didn't have the permission to do an auto assigning of IPs. So I did an alternative method where I could do an elastic IPs and then give IP for my environment. Next, I have NAT gateway. So NAT gateway here, that's where basically it sits on the public. Connectivity type is public, so it sits on the public, but allowing private subnets to have a secure route to the internet access. And now next I have in the security. So there's 2 different type of security that I use here: NetACL for access control list and security group. So NetACL, network ACL, that is security access control list, basically works on the subnet level. So it gives the subnet level a more secure layer on the subnet level. So I have private NACL and public. So in the private, I have inbound rules. Only MySQL is allowed, and the second one, that is only for the testing purposes. And for the public NACL, I have access for the HTTP for web servers and SSH for allowing instances to connect to the through SSH portals. And then finally, for security, we have the similar inbound rules and outbound rules for security. So if you see here, we have the inbound rules and outbound rules for HTTP and HTTPS, allowing it to access the web servers, and SSH for an inbound rules. Okay, and finally we have VPNs here. VPN is for, I've created a customer gateway VPN, and with the help of customer gateway VPN and VPG, which is virtual private gateway, we can have provide a secure access for accessing an administrator from a remote area just straight into the public subnet. And I basically divided a public and private subnet within the VPC for allowing, for example, public subnets for web servers, allowing access to the web servers, whereas private subnets for databases and sensitive informations. So just give a quick demonstration on our website on this instance and the public address. So it doesn't work because EC2 itself does not allow access to this internet with HTTPS. So I remove the HTTP, convert it to HTTP, and then we see finance web server running. That's an HTML index.html file that I have put in the EC2 instance. Now if I put a lecture here, so this is another file that I've uploaded in the cloud. So we can basically see the network is functioning perfectly fine. And if I go to edit route and remove this, remove this IGW that actually gives an access to internet and save changes. Okay, now if I try to visit this website, it does not work. Or I can just go to Internet Gateway and just detach my Internet Gateway from the VPC. That will basically cut the internet access. And finally, to access the EC2 from the SSH, you can basically do it from a PuTTY or WSL that I've done and connected using a tool here, SSH, and gotten access to the EC2 instance and uploaded all my files here. So that's it for my presentation. Thank you.